All right, here we are back again. New background. Y'all gotta tell me how this stuff looks. Kind of looks weird to me. But anyway, here we go. All right, so we are sharing now so we can get to our next lesson. Our next lesson starts right here on our next page with problem number 21, talking about OR problems. So here we are looking at OR now. So what we have to remember about OR, so let's go back. We just looked at and looked at doing some and problems. What we remember about and is that we multiply with and. It's kind of looking at using our fundamental counting principles, so to speak, with it, where we're multiplying our results. We looked at independent and dependent events, where we were replacing and not replacing our items, and how that affects our first event with our second event, and then being able to use our different skill sets with our cards. So we were introduced fully to our deck of cards. And then still being giving examples for rolling a die or flipping a coin and looking at those types of events. So now we're going to pick up OR. So remember, and we multiply. Let's see what we do with OR now. So problem number 21. It says, suppose we have a deck of cards. Again, we're looking at our deck of cards. And we are selecting one card at random. Find the probability of each of the following. Okay. So now let's refresh. We're looking at a deck of cards. So we know that our denominator is going to be 52 for the standard deck of cards. We're selecting one card at random, okay? And then we're going to find the probability of the following. So now let's think about what we're talking about. They want us to tell what's the probability of getting a king, the first fold, right? Or a queen. So probability, we're pulling this one card. So we got this deck, we shuffle it, we spread it out, right? Kind of like a magician. And then we pick the one card. What is the probability of us getting a king or a queen with that one card? And remember, or means that we're looking at all the kings possibility and the queen possibilities. We're going to add those things up. So here's what we're going to do. We know that our denominator is 52. So we have 52 cards in the deck. The probability of us getting a king. How many kings do we have in the deck? We got 4. So we're going to have probability of us getting a king is 4 out of 52. Then we're going to add the probability of us getting a queen. How many queens do we have? We have 4. So that would be 4 out of 52. Now remember, that one card could either be a king or a queen, right? So we have 4 chances of it being a king or 4 chances of it being a queen. But then we have to think about it. We have to do mutually exclusive or not. Is there a chance in the deck, think about it, is there a card in our deck that could be a king and a queen together? Is it? No. All right. So a card being a king and a queen together, there's no overlap there. So these events are mutually exclusive from each other. All right. So when you're dealing with OR, we have to think about the possibility of overlap, because we cannot double count stuff. This kind of brings us back to our previous unit where we were dealing with our Venn diagrams and how we had to set them up. So if we had two sets and we were setting them up, we had to start in the middle by filling that in, and then we would then see how many was just left in the circle, right, by subtracting the overlap. That's what we got to do here, right? We're going to look at the probabilities of these events happening and then add them together, but then we got to subtract the overlap so that we don't double dip. Okay, so if it helps to write out your structure first, let's do that. And I'm going to show us a couple of ways of how to write this out so we can keep our thoughts straight, right? So we're going to subtract out the overlap, and there is no overlap, so it's like subtracting out a 0. Let's finish up the problem. When we add this together, we get 8 over 52. Does that reduce? Yeah. Remember, we could put it in our calculator, or if you want to do it by hand, again, that's your choice, okay? But it does reduce. Again, you probably can put this in your your homework, and it will give you the correct answer. Again, follow the directions as well, of course. But if you put it in and it gives it to you as a correct answer, that's great. You reduce it and it gives it to you correct, that's wonderful, okay? So it reduces to 2 over 13. Now here's what we did. How many kings do we have? We're going to list it out. So write a list of the possibilities of what's going on. So we have 4 kings. How many queens? 4 queens. Is there a possibility that there's a card that could be both a king and a queen? Nope. So no overlap. So you're going to have your probability of your first thing, probability of your second thing, and then the probability of the overlap, right? So because there's no overlap, again, mutually exclusive events, all right? So you take this, add, right? Subtract the overlap. Let's try the second one. Now, still we can list out, or we can write them separately. I just joined here our numerators because the denominators are going to be the same. But you can write these out as 3 separate fractions if that makes you feel better, and it will look like this. So let's look at the probability of getting a red card. Now remember, a red card. So how many red cards do we have in the deck? We should have 2 suits that are red cards. So that totals up to be 26 out of 52. Then I'm going to add that to the probability of getting a queen. We know how many we said that was. 4 out of 52. Now, we have a red card and a queen. Is there a card in the deck that could be a red card and a queen at the same time? Yes. How many? 2. A heart and a diamond, right? So I'm going to subtract out 2 out of 52. There's 2 cards in there that could be a red card and a queen. All right, does everybody understand that? So we have possibility of getting a red card is 26 out of 52. Probability of getting a queen is only 4 queens in the deck, so that's 4 out of 52. But then the overlap would be those 2 cards that could be a queen and a red card, which is your hearts and your diamonds. We got to subtract those out because they're already added in or counted into the probability of our first 2 things happening. So we got to subtract it out. Now here's our list. So again, listing it out so we can see. So we have 26 red cards, 4 queens, and we have 2 as both. All right. So we have the overlap. That means we got to subtract. Okay. Now let's do the math. Again, you can put this in your calculator, or you can do your individual math. Here we could just add 26 plus 4 gives us 30. 30 minus 2 is 28. 28 over 52, which we know can reduce to 7 over 13. So with OR, we're adding up the probabilities and subtracting the overlap. With AND, we're multiplying the probabilities. Okay? You can pause the video here now and try these next 4. Right? And then we can come back and we'll work the check our answers together. Okay? All right, here we go. A club or a 10. So how many clubs do we have? We have 13 out of 52. I'm going to go ahead and write it all as 1 now. Then how many 10s do we have? We have 4 10s. Now, do we have a card that could be a club and a 10 at the same time? Yes, we only have 1 of them. Again, remember, you're going to have your deck of cards with you, so you can look if you don't remember, okay? I just happen to remember because I play cards, all right? But don't worry about it. You don't have to remember or memorize the deck. It does help if you are familiar with it. So do get familiar with your deck of cards. Then when we add and subtract, so 13 plus 4 is 17. 17 minus 1 is 16. 16 over 52. And then you can put this again in your calculator. When you put it in your calculator and then simplify it to see if it can be reduced, it can. 4 over 13. All right. Black or ace? Black card. How many black cards do we have? 26. How many aces do we have? We have 4. Do we have a card that could be black and an ace? We do. We have 2 of them. So subtract 2. And then we're going to do our math. So we have 30 minus 2 is, yes, which we know, if you look, we already did the math up here, right? Okay, so we know that's still going to give us 28 over 52, which equals 7 over 13. You see how a lot of times when you're dealing with a lot of the problems, you've already done it already. So a lot of the numbers should be familiar with you, to you as you start moving through the examples, talking about the cards. You'll see, oh yeah, I know that this is how many in the deck. Oh, okay, I remember, yes. I know that I did this, I added this, yes, it's going to reduce to this. You don't even have to do it in the calculator anymore because you already reduced it before, right? The probability of ace or a face card. All right, so here we are with our denominator, standard 52. How many aces do we have? 4. How many face cards do we have? Remember now, face cards, we got 3 per suit. So 3 times 4 is That's right, 12. And then, do we have any aces that can be face cards? Do we? Okay, so you don't have to write the -0 here. If it makes you feel better, put it. But if it's nothing there, if it's going to be a -0, you don't have to write it. So we have 4 plus 12, 16 over 52, which we know reduces to 4 over 13. Right? Then we have the probability. All right, probability of a black or face card. All right, so probability of a black card. Now remember, we got 2 suits that are black, so that would be 26. Then we have face cards. We know that we have 12. Now, do we have a situation where we have some overlap, where we have a black card that can be a face card? Think about it. How many? So we should have 3 clubs and 3 spades. That's right. So -6. So again, you can go back and look. You should have 3 spades and 3 clubs. Those are your black cards. And they have those face cards. So -6. And then when we do our magic, we add and subtract. This gives us 32 over 52, which equals 8 over 13. Right? So looking at our OR, remembering that we add them together, the probabilities together, and subtract out the overlap. All right, number 22. Suppose we draw 2 cards without replacement. What is the probability of both being aces? Now look how they worded this. The probability of both being aces. We're drawing 2 cards, okay, without replacement. What is the probability of both being aces? This right here is an AND problem. Now, if it's an OR problem, they're going to tell you right out it's going to be an OR problem. But here we see when you're drawing 2 cards in succession, they didn't give us the word succession here, but they implied it. They told us without replacement. What is the probability that both of those cards would be aces? That is an AND problem. So we're talking about the probability of you getting an ace the first time and an ace the second time. Okay? So remember what we said, that with AND, we're going to be multiplying the 2 probabilities together. But now because we're not replacing, okay, so without replacement, remember that means that our second pull is going to be affected by our first pull. So we're talking about the probability of ace of 1, right, times the probability of ace of 2, given that ace of 1 really happened. Okay, so if this turned out to be an ace, then the probability of ace of 2 happening. All right, so how many aces do we have in the deck? We pull 4 out of 52 times, if this is an ace, right, and we don't put it back in the deck, then we know that we're not going to have 52 cards anymore, right? We're only going to have 51 in the deck. And then we don't have 4 aces anymore, but we have 3 aces, right? Okay. So then when we do our math, here we need the calculator for that one. So we have 4 divided by 52. And I'm putting the whole thing in so we could see it, or you could just multiply across and get 3 times 4 is 12, right? And then do your times 52 over 51, however you feel comfortable putting it in, you know that, times 3 divided by 51. There's your funky decimal. See if we can write it as a reduced fraction. And we can, 1 over 221. So here is our answer. But be careful again. This is an and problem. So 2 events without replacement, all right, and using and, not, you're using and, not or. All right, let's move on. Moving to our next page. Uh-oh. Okay, so here we are, moving on to problem number 23. All right, so we are looking at survey information. So now we're moving into our conditional probability. Conditional probability, our keyword here. So now we're looking at a sample size and now shrinking it down to size is what we're doing. So when we're looking at conditional probability, how do we know it's conditional? We have a keyword, given. So here we'll see now in our problem, we're going to be using this word given that tells us what we're talking about. And that's going to be our conditional probability, what's happening, and how we're going to narrow down what's going on. So let's kind of talk about what's happening. We have this survey information. We want to suppose that each person surveyed only owns 1 pet, right? You have males, females in your total columns. Now remember, when you're dealing with probability, totals matter. So if in the homework or on the test, if you have a table or a chart and they don't give you a totals columns or row, then you have to find this total column or row. So you have to add things up so you can get your total, all right? So watch out for that. Totals are important. Here they gave it to us. You say thank you and you move on. We have a dog column, a cat, snake, ferrets, all right? And then totals up at the bottom. Here's your totals for your male and female, and everything should add up to 23, okay? Now, it says, find each of the following. A, the probability of male owner given owns a snake. Now, so here we're looking. Male given snake. So first things first, you're looking for the probability, and this is how it's going to be written. So if they don't give you the words, they'll give you the symbols. So the probability of a male given. So we've looked at this slash before, and that means word given, that he owns a snake. When you're setting up this math statement, this word given, okay, tells us that we are only focusing on a specific piece of information in our table. So now if we're looking just for general probability of something, then we're going to use our total number, which would be 23. But here, they're asking us the probability of a male owner given that he owns a snake. So when we're setting this up, you're looking at this as if it's a fraction, because that's what it is. So snake represents your denominator, okay? So your second part of your given statement is your denominator, and the top part here is your numerator. So always kind of helps me, and you can do it out however you feel comfortable, but I always focus on the denominator first, because then I can see the total number of what I'm talking about. So when I look at the snake column, I need the total number of snakes. So here I'm looking at snakes, and there's a total number of 2. So I know that's going to be my denominator. Then the question is, out of these 2 snakes, how many of them are males that own them? Okay. Well, there's only 2 males that own snakes. Let me do it one more time. So the probability of a male owner, given that they own a snake, the male represents my numerator. The snake represents my denominator. So anything before given is the numerator. After the word given is the denominator. I looked at my chart at the total number of snakes. That would be 2. And then out of those 2, that total, how many of them were owned by males? So then I went up to my chart and I realized that the 2 snakes that were totaled, they were owned by males. So that was my numerator. Then I can reduce it and I get 1. Make sense? Let's try another one. Probability of owning a snake given male owner. So you see they switched it. Oh. So you have owning a snake given the male. So here we have the probability of a snake, right? Owning a snake given he's male. So remember, it's my denominator, it's my numerator. So now I'm looking at the total number of males I have. So now remember, you got to look at the right column or row. So here's my males, the total number of males that I have, 14. That's my denominator. But out of these 14 males, how many of them own a snake? So out of the 14 males, how many own a snake? 2. And we could simplify. 2 goes into 14 7 times, so 1/7. Okay, how do we feel about it? Conditional probability. Our key word to look for, given. All right. So if we don't see that word, then we're not dealing with a conditional probability. You can pause the tape right here and see if we can do our next 2. Now watch it. For D and E, I don't see the word given, but I do see some familiar words that we know. Give it a try and then come back. Okay, let's check what we have. Leave the table there so we can see it. All right, so C says the probability of owning a dog given female owner. So here we have, writing out my structure, probability of owning a dog given female, right? So I know I'm looking for a total number of females that own a dog. How many females do I have? Total number right there is 9. And out of those 9, how many own a dog? So here's the 9 total. How many own a dog? 1. No need to simplify that. 1/9. Okay. The next one, probability of a female owner and owns a dog. Now you notice here they changed the word. So now we have and. What do we know about and? We're going to, right, think about it. You have a female dog, female owner, and owns a dog. So we're looking at our table to look to see how many females owned a dog. Okay, here's my females owning a dog right there. How many out of the total number of people who participated in the survey? 1 out of 23. So this is where we actually are using our total of our total participants, right, for our denominator. So the probability, excuse me, probability of female and dog would be 1 over 23. Okay, so what do we know? There was no given there, so no restriction. All right, our sample space, you know, for our denominator, we're using our total number of 23, and we were looking for females who owned a dog. The total number that we had there was 1 over the total number of participants, which was 23. Now look at E. They changed the word again now. Probability of female owner or owns a dog. So now, what do we know about or? We need to look at the probability of being a female plus the probability of owning a dog. And then if there's any overlap, we gotta subtract it out. So remember our process there for or. Let's do it. Now, if it helps, write out your structure. So we know it's probability of female or dog. Remember our denominator is 23. Still talking about the total probability, so the total number who will always participating in our study. Now, how many females do we have? Look at the top table, and I know you figured it out all the way over here, 9. Then how many dogs do we have? You see it, 6. Training our eye to read our table. You're going to have tables, you're going to have charts, you're going to have pie graphs, you're going to have bar graphs. Being able to interpret and read what they give you is very important. Now, is there a column that represents where you have a female who also owned a dog? We do. So we have a female who owned a dog right here. How many is that? 1. We got to subtract that out. Yeah. Okay, so we got the probability of a female, probability of a dog, subtract out the overlap. We're ready to do the math. So we have 9 plus 6 gives us 15. 15 minus 1 is 14. 14 over 23. Can this be reduced? No. So 14 over 23 is our result. So make sure you're paying attention to, again, the wording. They're giving you and. Then you are simply looking at what they're asking you for. Here they're asking us for a female owner and owns a dog. Okay, so we're looking at where that is represented in our table. If we were doing 2 events, then that's different. Here we were just looking for the 1 event. If they give you or, Or you're going to find the probability of each event, then subtract out the overlap. If it's a conditional probability, which we just picked up, you're looking for that keyword given. That's how you're going to tell. And then you're going to write out your structure. And you know that anything before, look at it as a fraction. Before is your numerator. After the line is your denominator. It always helps to start with the denominator first. And then from that number, you're going to identify your numerator. Okay? All right, let's move to 24. Okay, suppose a standard deck of cards. Find each of the following. So they could, instead of writing it all out in words, here we are kind of writing it out. They're giving us our structure. It says probability of a queen given a red. So a queen given a red. So instead of giving us the slash, they're actually giving us the word given. Still means the same thing. So again, you have before the word given and after the word given. So if it helps to draw the arrows, do it. So you have your denominator and your numerator. How many red cards do we have? Again, just red cards. You know, that's 26. But out of those 26, how many of them are queens? We know that there's 2. So you see, again, that word given shrinks our sample size down and lets us look specifically at a targeted group. So now we can simplify 2 over 26 and we get 1 over 13. Okay. Now you can pause the video and try these next 2. Remember, next 3. Look for your words. If it doesn't have it, then you're not using the conditional probability. All right, see you when you come back. Okay, let's check out what you have. So here we have probability of a red given a queen. So now they've changed the order now. So we're looking for red given a queen. So how many queens do we have in the deck? We have 4. Out of those 4, how many of them are red? Just 2. That reduces to 1/2. All right. So we see just by changing the order, it really just brings our amount down significantly, right? All right. Let me see. Probability of a red queen. Did they give us the word given? Nope. We don't have an and or. We just want to know what's the probability of us getting a red queen. How many red queens do we have in the deck? How many? Yep, 2. 2 out of how many? 52. So here's our standard probability of our deck. So 2 out of 52, and that reduces to 1 over 26. So don't make it into something that's not. Make sure you're paying attention and reading the problem carefully. Here we said probability of a diamond given a black. So again, they're given the word given. We know we're dealing with conditional probability. So here's our denominator and our numerator. So how many black cards do we have? 26. Out of the 26 black cards, how many are diamonds? Okay, so think about it now. We know what diamonds are, and diamonds, are they red or black? They're red. So is this possible? Not possible. So out of these 26 black cards, how many of them are diamonds? None of them. So our answer is 0, which means can't happen. So remember, it's possible that that can be your answer, okay? Can't happen. follow your homework. It'll tell you how they want you to put it in. Okay, if they want you to put in a certain symbol or a certain wording, make sure you follow the directions for that. Right? But it can happen. All right, so I hope this helps. All right, make sure you're paying attention again, reading what the problem is giving you. Make sure you're looking at your sample size. Make sure you're paying attention to if they want a conditional probability. We know we're looking for the keyword given. That's right. Remember, and we're looking at multiplying our events together if it's more than one event. Or we add our events together and subtract out the overlap. All right. I hope this helps. See you next time.